Hi everyone. Is okay? Okay. Hi everyone. I'm Leon, and this talk is about how AI agents need AI gateways. And during this talk, we are going to go about how microservices work and why microservices, were the background of all the AI agents, right? Similarly, agents also are very micro pieces of software that we run, and they do one task, and then they exit or they communicate with different AI agents. So let's begin. So yeah, this is what we'll basically cover, but I usually don't go according to the agenda. So I'm going to be asking you all questions. How many people here have deployed microservices on Kubernetes? So basically when you deploy microservices, right, there are a lot of things that you need to do, right? For example, you need to do rate limiting between services so that you don't overwhelm your applications. You need to do things like TLS connectivity between applications, right? And a lot of these things sometimes have to be baked inside the microservice, right? So for example, if the microservice is like a cart microservice, but now I have to add a TLS certificate, I have to add a uh, SSL, or I need to add like a rate limiter, or I need to add some different library, and all these compound, right? So for example, it could be a microservice written in Python, it could be a microservice written in Golang, right? They both will have two different libraries. So you then have to sit and manage both the library versions and everything as such, right? So yeah, microservices is something that has been for a lot of time around. We initially started around with monoliths, right? Whereas it's a big VM that used to run, and you should do things like either run containers on it, or you should run the entire application on a VM. And for that, we used to use something which is a very common thing, right? A load balancer. Now, what happens with these VMs is that as you scale, you have to manage these beefy VMs, which is like a lot of compute, and half the time the compute is wasted. So we eventually moved on to Kubernetes, and then came microservices, right, where you could create a small pod on the machine, and it would you could do things like have multiple services for a single application. So if one thing went down in your application, the other parts of the website or the application would still work, right? So, but fast forward to today's world, what we have is AI agents, MCP servers, and none of these work with the traditional gateways, right? The traditional gateway, like Envoy, Nginx, any of these, they require you to only manipulate headers, or they only require you to send header or like something in the body, but you cannot manipulate that body, right? You cannot check the body and do different things. You can write like a Lua script or Nginx to check what's in the body and all that, and then you have to manage that too. So that's another thing that you have to sit and manage. AI agents are very similar, right? You get an agent that runs in a cluster, and it may be a LangChain agent, it may be an ADK agent, or anything as such, right? Now, for AI agents, most of the workloads are body-based, right? For example, if I have to send a model name in the body, right, I want my gateway to route it to that model, right? So when you run AI models, you have different models, right? Some are SLM models where it's like a small language model where you don't want to do like a lot of computations and all these things. And then you have the LLMs where it's like a larger language model, right? Where it may cost more, it can be expensive, and it takes a lot of time to maybe come back, right? With an AI native gateway, you get things like routing to MCPs, routing to A, and also LLM aware routing in the sense that the body of the LLM itself will be, you can inspect the body, you can route based on the model, you can route based on the header, based on a jot token, based on a claim in the token. So for monoliths, when we had, I think I went a little bit fast, but when we had microservices, you had two kinds of traffic, right? One is the north-south, and one is the east-west, right? And what we've seen is that people started using service mesh, something like HTO or Envoy for gateways, and for service mesh, which is your east-west traffic between clusters, people used to use MTLS and all these things, and the issue is HTO for that, right? So yeah, so moving on, this is the normal, OSI model for microservices, right? You have the application layer, you have the other layers here, and you have the proxies that you could run, like Envoy, Nginx, HA proxy, and all these things. The main common functions of things like a service mesh is it used to provide standardization, right? So for example, in HTO, I could take a single microservice or 10 microservices, and they could be just running transparently, right? And they wouldn't know that there's a timeout between, if they had a longer timeout, they had to bake it inside the application code, right? So with the service mesh, what you can do is you can just write a YAML file, and you can say that, okay, this service can only have a timeout of 50 seconds for the next service, right? Service A to service B. And what made it possible was that HTO used to add a sidecar, right? It used to inject its own code, not into the application, but as a sidecar in Kubernetes. Now what we have done is we have moved on from that model. We have a model called sidecar-less mesh, which is ambient mesh. Ambient mesh is something that runs very transparently. It has no sidecars. You only get L4 and L7 proxies. And most of the times, users don't even have to run the L7 proxy. They just run L4, and they do things like MTLS, TCP traffic, and all the metrics that are available, right? So with AI agents, we now have more compute, right? You need to have more compute. You need to have more resources. Latency has become something that is now nobody wants 200 milliseconds, right? Before microservices, you had 1 millisecond traffic and all these things. But with AI agents, since it's so body heavy, you expect the agent or or Claude or something like that to take at least 5 minutes, so you can go grab a coffee. And when you come back, Claude has finished doing its work. So basically, between a traditional API gateway and agentic traffic, you can see different things, right? In microservices, you could just send an HTTP request, and it used to give you a response, right? But with an AI gateway, we are expecting it to come with some computation that is done with an LLM. So you can do things like stateful connections, right? With gRPC, where it's it has the same state, and you keep communicating bidirectionally with every request with using the request ID or something like that. And we also have tools in LLMs, right? You can have a calculator tool that does addition or subtraction separately. And these all run within these agents. The other thing, the most important thing in today's world is token cost, right? With AI agents, the computational cost has gone higher, but also you have to be sure that you manage your tokens, you limit your token usage, or you will have bills which are very high. You must have seen all the Twitter posts and all where people get hit with a larger bill because they left their LLM on, or they left it running on the public web. And we also have things like agent-to-agent communication, right, and MCP communication. And with all of these, the way we communicate between agents has changed, right? You must have heard of things like elicitation, OBO, where one agent is trying to communicate with another agent, but it has to use a token, and the token has to be of the user that is calling it first. So there are things like STS token, where you do a token exchange between two agents, and all of this is very complicated to do on a normal gateway because they are traditional gateways, right? They're not meant for AI agents. So to introduce this OSS software, it's called Agent Gateway, and it's one of the latest additions to the Agentic AI Foundation, and it's also in the Linux Foundation. And we have a new layer, right? Now we have a context layer. So every LLM needs to have context of the previous call, and with that, you need to have bidirectional communication, stateful connections. You also need to be able to, switch between models, route between different models and all. And all of this is done natively with Agent Gateway. So basically, you don't have to do additional stuff, right? You're mostly doing things like unified model providing. So if I give a single endpoint, I could switch between multiple models just by specifying the model name in the body. So I don't need to, on the back end sit and write, okay, maybe /GPT only goes to ChatGPT or /Claude only goes to Claude. You can do it on a single endpoint just by body-based routing, and it also works natively on the gateway. And the advantage of this is that it's a Rust-based gateway, so it's very system-friendly and memory-friendly. And what we have done is we have implemented something called as cell expressions, common language expressions. Basically, you can write cell on the gateway, and your request, like things like jot.sub, can be equal to something on the gateway. So you don't need to have a separate, service that runs, that checks. The number of hops that you need to do something is reduced. So yeah, why not traditional gateways, right? What is wrong with something like Envoy? So the company that I work with, we built over Envoy for almost a decade. The product was called Glue Edge, and it was open source. What we used to do is that we used to do traditional gateways in Kubernetes. So we had things like rate limiting, we had things like transformations, we had things like you could do shadow traffic on the gateway itself, and all of this was managed in Kubernetes. So you did not need to write a config file. You just need to write a YAML file in Kubernetes. The controller would translate it to Envoy, and it would then run it in the gateway. So what has changed between these traditional gateways and something like agent gateway? So when you do traditional routing, you can do things like rate limiting and all these things, right? But what about token-based routing or token-based rate limiting? You cannot effectively just rate limit on each token, right? Because the tokens are cumulative. So you cannot do like, okay, I can rate limit on 5 tokens. Because there's a burst of traffic with the number of tokens. So that's how we have built a data plane that understands AI agents, so it can communicate with it more effectively. So the 4 jobs of agent gateway or any AI native gateway would be something like this. One is an LLM gateway. So you should be able to route to an LLM with things like OpenAPI compatibility. So we've seen the chat v2 completions, right, or chat v1 completions. Now what if I told you that for each chat you had to create a separate endpoint? But with agent gateway, you can create a single endpoint, which is the chat completions, and you can route it based on the model you provide. So we do a lot of content-based routing, and I will also, if I have enough time, show you a little bit of the documentation that we have. We also do MCP gateway, so we do tool-based federation. We do things like OpenAPI integration. We also have a UI with the agent gateway, so you can see a lot of different things, and I'll show that in the demo. We also do inference routing with the inference API that is in the CNCF. So we can route to things like VLLM. Local model routing is also a thing with agent gateway. And this is all part of the OSS stuff that we have. So we integrate with a lot of different CNCF, Linux Foundation projects that are available open source. So you can do things like external authentication. You can do things like reaching out to different provider, like using XProc, which is like an external processor. So if I want to maybe log every request with something like OPIC or something like that, I can just add it on the gateway, and it will do another call to OPIC, and then come back and do it, and it's all async. So none of these connections will be blocking, and they all run parallel to the gateway. So the data plane that we have is something like this, where you can do AI agents. You can also route to normal Kubernetes services that are in the cluster. So you don't need to run 2 separate gateways. Because we support Gateway API, you can use Gateway API to route to an agent gateway backend, or you can route it to a normal backend that is Kubernetes Gateway API conformant. And we also do things like policy, budgets. I will show a demo about the cost and the budgets. And yeah, we do A2A, we do MCP, and LLM providers, right? So all of this comes under the same agent gateway product. You don't need to switch between products. Yeah, and this is one of the most common thing that we are now seeing, where you have multiple AI agents, and you need to do things like reach out to 2 different agents, and get back a response. So one of the good things is that we can also integrate with HTO ambient mesh, and we can do things like east, west, north, south, both inside the mesh, using agent gateway as a waypoint. And yeah, we also do a lot of policies, which I will show in the documentation. So yeah, this is a small rhyme of how API gateways came out, and service meshes to microservices, and AI native gateways to agents. So yeah, these are the three main things about Agent Gateway. We are first of all in the Linux Foundation. We are also in the Agentic AI Foundation, along with projects like Goose and all these things. We also have a compliance with Gateway API. So we are every Gateway API version that comes out, the next version we release is conformant with Gateway API. The current one is, I think, 1.6. We also have Apache 2.0 license, so you can run it on your own clusters. You can also run it as a standalone. So you don't need a Kubernetes cluster. You can run it on a VM. You can run it in a Docker container. One of the demos is a standalone demo, so we'll see that soon. So yeah, this is a slide of the traditional API gateway versus agent gateway and how it works, right? So you can see there's a connection model which is stateless. Versus an AI routing which is stateful. You also have like just one request, right? You do a request, you get a response. But in AI workloads, you're expecting like a chat or something like that, which is like a long-lived connection. You also have like routing logic based on paths, headers. So you can do various types of routing with Agent Gateway. And you can also do like static backends. So you don't need to have your AI agent running in the cluster. If it's like a remote AI agent running on a different cloud or something like that, you can still route it using a static backend. And it supports all the same things as a normal AI gateway or API things that you would have. And we also do like JSON RPC routing. So you can do bidirectional SSE events and all these things in the MCP inspector tool where you use the SSE protocol. You can do that also with Agent Gateway. It supports it out of the box. So yeah, one of the cool things about Agent Gateway is we are very open to service mesh because we've been doing service mesh for so long. It was a very logical step in a Kubernetes environment. Because the way it works, right, is AI agents also need transparent security, right? Nowadays, we see AI agents breaking out of containers, breaking out of VMs, and all these things. But with something like a service mesh or like an ambient mesh, the connection is very transparent to the network, right? So if I'm calling another AI agent and I can't access it, I cannot access it. The application isn't aware of what is blocking it in the first place because it works in a very transparent way, node to node, right? The ambient mesh does this. It basically reroutes every traffic from the node to its L4 proxy where it does MTLS and all these things. And if you need L7 capabilities like rate limiting or something like that, that is where the waypoint comes into place. And what we've done with Agent Gateway is we've replaced the normal traditional HTO waypoint with Agent Gateway as a waypoint. So you get all the functionalities that Agent Gateway provides in a normal AI gateway in the mesh. So you can do the same policies and all that you're running in Kubernetes with Agent Gateway with the service mesh integration. And you also get like a unified control plane with K-Gateway, which is another open source project that we have, which is still based on Envoy. So yeah, also the open source community of Agent Gateways is quite high. We have a lot of good contributors and a lot of different companies that are communicating with us, and we also do a lot of case studies with them. We have a lot of big companies that are using Agent Gateway today. We also have this new and upcoming thing. I don't know if a lot of people have heard about this. It's called Agent Substrate, and it is something by Google that we are working with Google to build out, basically. And the way it works is that it replaces agent sandboxes. Because sandboxes are still, you need context within a sandbox. So you eventually run into things where you mount files into a sandbox. You have to do all that. Agent Substrate works in a different way. But today we are not going to discuss that because it's still up and coming. So it's not something that's still out there with all the documentation and all these things. But it is an upcoming project by Google. So yeah, we are also part of the Agentic AI Foundation with these projects like agent.md, MCP, Goose, and one of our projects, Agent Gateway. Oh, there was a transition, sorry. So yeah, every time software changes, right, we also have to change the infrastructure with it, right? There was monoliths where you used to run like a single rack, and there was a load balancer that was a different VM that used to route traffic. Now we have microservices where you run multiple microservices, and then you need a gateway to route traffic to them. Because exposing all the microservices without a single endpoint is very dangerous, right? And now we have agents running in Kubernetes, running in VMs, where you have to route traffic and secure traffic. So we have to sort of change the infrastructure every time we move on with the software. So let's do a demo. Okay, let's try doing a demo. So is this visible to the back people? Should I zoom in more? Can you see the text on the screen? Okay, thank you. Right, so the first one that we are going to do is going to be on the cost. So this is a standalone gateway. So okay, so we have the dashboard. Is it too big? Okay. Maybe the dark theme is better. Okay. So what I want to show here is basically the cost dashboard. So in a company, right, you can have your own LLM models, or you can have your own software running, and you want to set your own cost, right? For example, GPT on the latest Soul model takes like a lot of money. So you want to set your own cost for it. So you can do it with this budgeting tool. And you can then see the analytics here where you can see the traffic. So for example, right now there are already 5,000 requests that are made. And it will show you, how much money is used along with how many tokens. So for example, you can also do something like last 1 hour, right? And we will just run a real call to the LLMs. So right now I'm running like a real call to the LLM models. And you can see the calls have increased and the amount of tokens that are being used. And give it some time. It might take a few minutes to refresh if there are more calls. So yeah, you can see here the calls are updated now to 23, and you can see the amount or the cost that was incurred for this. And you can do things like, you can check the breakdowns of the tokens. You can also see the logs in the UI as to what the request was and how it is. You can also see the raw logs here that show all the tokens and all these things. And yeah, so this is one demo, and I want to show the other demo, that is the virtual MCP. So in the virtual MCP, what we do is we have multiple MCP servers, and we have multiple tools in these servers. So let's do a step by step. So I have just already created this cluster because it will take some time. And let me zoom this out. And we are just installing the gateway API CRDs. So this is a virtual MCP. Let me. Yeah, this is better. So virtual MCP is basically multiplexing multiple MCP servers with all the tools it has. So basically, if I have 10 MCP servers, I can multiplex it all into one endpoint, and you can federate all the MCP servers without them knowing they are federated. So what this gives you is basically tomorrow, if you want to restrict a tool from the MCP, you can just write a rule in the policies, and the MCP doesn't know that the tool has been removed. So for the MCP, this is a transparent process. There is no code changes, there's nothing, because this is happening on the gateway. Basically, when I send a request, if I have listed a tool to not have access, the tool will not even show up in the federation. So basically what we've done here is we've got two MCP servers, and we've multiplexed it into one MCP server. So if you see the next one, it will install the agent gateway, right, in Kubernetes. So the agent gateway pods are running. One is the controller and one is the proxy pod. And we have two MCP servers, right? We have MCP server everything that has all these tools, and you have MCP server tools which has a different set of tools, right? Oh wait, this is same tools. Weird. But yeah, so I'm not sure why they're the same tools, but basically the idea is that you have two separate MCP servers, and you will have the MCP server running. And what we do is, now the server is running, right? And it has a streamable HTTP port. So let's try to run it. So what we've done here is we've created these, something called as an agent gateway backend. So if you look up here, it says agent gateway backend. And what it does is, basically, agent gateway backend is all agentic AI backends. And you can do things like two targets here. And now these are federated automatically. You don't need to do any code changes, nothing. All you have to do is select the services that are running in the cluster with a label selector. And using that, it gets federated. So next, we'll create like a gateway API listener. And basically, it will create like a gateway, and it will create an HTTP route. So if you look here, we've created like an HTTP route, which is what Kubernetes uses, right, in the gateway API. And we only have a single /MCP prefix, which routes to the agent gateway backend that we created. And now we'll just run this. Okay, so it's already running. And now we'll just call the MCP URL. Okay, let me do this. Okay, so we can run a test suite and we'll see how it runs. So let's run a test suite. So this is the initial MCP initialization, where you just reach to the MCP with the body, and we'll just hit return. And you can see we got a body from the MCP with all the details that it was given. So we asked it to initialize itself, and it tells us what it's doing, what it has. Like it has the MCP server, everything, and also the MCP server tools. So it's 2 different MCP servers. And now let's do a second test. So this is a federated tools list, right? Both the MCP servers are federated under one single endpoint. And if we call it, you can see there are like a lot of number of tools that are federated under a single MCP endpoint, right? So you can have like 20 MCP servers federated under one MCP URL, and you can decide if you want to hide tools or you want to give tool access based on the users or anything as such that you want to do. You can do things like external authentication, where you get like a JOT token, and the JOT token, based on the JOT token, you can decide, if this user can access this tool using a cell expression, which is not shown here, but it's one of the things. And the other one is like an echo call, right? So we've only given the tool name, and we've told it to do this hello from agent gateway, and it's still under the MCP server, right? So it will select on its own which tool it has to call, and you get the response from the backend. And since these are federated, right? So it will check which tool it has to call from both the servers, and then you get a response back. So yeah, that is it for the demo. So we did the 3 things, and we got the responses. So yeah, you can see what all was covered in this, right? You can see that we have multiple MCPs, and we created a virtual MCP out of these MCP servers, and then we do a single endpoint, and after that we do like a federated tool discovery. And the way it is done is using JSON RPC or streamable HTTP. And yes, so this is it. If you want, you can scan this link. I still need to upload a little bit of things, but it lists all the projects that we have, and eventually I'll be adding the blogs that we have on Agent Gateway and all these things under this link. But yeah, you can always go to agentgateway.dev. And you can see all the features that we have for LLM, for inference routing, for MCP connectivity, and all this runs both on Kubernetes as well as a standalone binary. So you can run it on Kubernetes, you can run it on a VM, you can run it in a Docker container. And we have a lot of integrations with things like VLLM, semantic router, LLM, MCP clients, and all these things, Kserve, Argo rollouts, all out of the box. So yeah, that's about it.